Hello and welcome to DigFin VOX, the voice of digital finance. I am your host, James DiBiasio. Our guest today is Andreas Burner, Chief Innovation Officer at SmartStream Technologies. Andreas spoke about artificial intelligence and in particular machine learning, the way that it's being deployed by financial institutions, where the technology is coming from, where it's headed, some of the ways that it's being turbocharged, like in areas of hardware and cloud, some issues that still linger, explainability, how to get creaky legacy IT to be able to make sense of all of this data and analytics. And finally, the way that AI is being combined with other next-gen technologies such as blockchain to create even more value add for financial institutions. So please welcome Andreas Burner. So Andreas, welcome to DigFin VOX.
Thank you for having me, James.
All the way from Vienna. So it's a pleasure to have you on the show. You and I have spoken before. You have a career in artificial intelligence. Tell me, what is the big problem today that artificial intelligence is trying to solve when it comes to financial services?
Oh, that's a big question, James. So financial services is specifically interesting for AI and machine learning because we always have big data everywhere, right? Everywhere in financial services, we have millions of transactions. We have thousands of workflows, how we deal with everything. And it's very structured, but also very time intensive to do financial services. So it's actually a sweet spot for machine learning and artificial intelligence. We in SmartStream, we are in the reconciliation area, which has to deal with many transactions. So that's again a very specific area, but also in other areas where in the payment industry or so, you have a lot of similar workflows and transactions, and machine learning is perfect for that.
Yeah. How has the machine learning use cases and technology itself evolved in the past, let's say 5 to 8 years? You know, is it at a level where it is quite sophisticated now, or are we still very much where if you want to create a machine learning style program, there's still a huge need for data scientists to be feeding the machine constant data and experimenting and going down blind alleys and not quite knowing when you're done? And how far along are we with this?
That's a good point. Yeah. So I would say both at the moment. So how it involved at the moment, the interesting thing is that the cloud providers, all the Amazons and Azures, Microsoft Azure and Google, they provide machine learning infrastructure. And not only infrastructure, they also provide workflows for machine learning. So you can do many things on the cloud you couldn't do easily before. You know, in machine learning, a lot has to do with testing and seeing what are the right hyperparameters, so really tweaking the algorithms. And what you can do now, what you couldn't do before, is you can just purchase on Amazon 20, 30 huge machines, run your optimization there, and within an hour you have your results back. Before you had, as a bank or as a big company, you maybe had 1 or 2 machines and it took several days to do the same thing. So I think we advanced a lot in terms of processing power, because the cloud technology now also has this domain of machine learning. But on the other hand, it's still very much how you run the workflows. I see a lot of companies that doing POCs and custom machine learning tasks specifically for their needs. And it's the same like with every software product. You can either do it customized or you buy a standard product, which does the job 90% for you, and then you just customize a bit. And I mean, we can talk about the pros and cons a bit later maybe, but it's it is still I see a lot of POCs where it's still a trial and error topic. You have some data, you try that algorithm, this algorithm, it works, then optimize it a bit. This is not the way we are doing it, but I still see it a lot out there. Yes, and that is data science expensive if you do it in that way. Yeah.
Right, because you're paying people to do all that trial and error.
Correct, yeah. And they have to evaluate. Evaluation is also a data science job. And evaluation is super time expensive, right? It takes a lot of time.
So how much of the data science work, that kind of day in, day out training and evaluation, is now being able, if you're either making it more cheap and fast if you put it on the cloud, or just it's being automated itself?
So I would say from a typical data science job, scientist job, a lot has to do with data preparation at the moment, where you have to tweak the data so that it works for the machine learning algorithms. Then you really train the algorithm, which needs a lot of knowledge, but it's like playing golf, right? Where you hit the ball and it just has a contact of a millisecond and then it flies a long, long way. And the same is true for machine learning.
Not when I'm playing golf.
I'm not playing golf. So
yeah, I'm lucky if I just make contact, you know.
But it's a bit the same. So you have a very short time where you have the contact with a machine learning algorithm, and then it trains a long time and predicts a long time, and only then you get the results. So you have to be very good in that millisecond. It's of course a day or two where you implement that algorithm, right? And then again, a lot has to do with verification in the end. Was it good? What was not good? How can we do it better? And it's a iterative process. It's very time consuming if you do it that way. We in SmartStream, when we started 2 years ago, we had a different approach because we come from the software industry and not from the data domain. And in the software industry, everybody learned very early that it's not clever to have customized products, but better to have products off the shelf that you customize, because it takes 90% away from the time that needs to be put into those products. So we really try to implement something which works for every reconciliation or for every cash and liquidity problem, and then only customize it on site. So we can minimize those times, but still it's a very time-consuming task, data science these days. Yeah.
Yeah. Do you see that changing? I mean, just curious as to, you're an expert in this field. So where do you see the field going? Before we talk about some of the actual use cases, where do you see the advances in the machine learning and the data science itself?
Yes. So a lot has to do at the moment with explainability still. I think we talked about it a year ago, but explaining a machine learning algorithm is still something everybody wants to have. And the better they can explain themselves, the better it is. We recently used Bayesian neural networks, which is a very mathematical approach that can fully explain themselves with probabilities and confidence values. So you always, when you train an algorithm, even as a user, you always have a very nice overview as a curve, how well the algorithm itself thinks, how good it understands the data. So it says 60%, and you would understand that from the things you have to do, 60% is probably right of what it's proposing. And when you're at 99%, it means to us users a different thing. So it's very important, the explainability. And the other thing which is happening at the moment is really in the infrastructure domain. So when we approach banks at the moment with our technology, only then I see that how big the gap is between the data science and fintech community and what a bank really is able to deploy. So we use, for example, for some algorithms, high performance graphic cards, because only they can produce the power we have, right? The normal computer has 30 CPUs and the graphic card has 3,000, and we use 4 of them. So we have 12,000 CPUs on that graphic card. it doesn't cost a lot, but for a bank, it's a complete different subject to order and to purchase a normal computer than one with graphic cards, because still it's a gamer's thing, right? So I always
You mean because the
feel
graphics are, they associate their procurement people think, oh, that's for video games. Why do we need it?
right, yeah, for cutting videos, for video games, and so on, right? So when I'm in that discussion, we try to produce machine learning software that works on every machine. But if you go into in these high performance areas, graphic cards are very useful. And then I'm in that discussion with an infrastructure department in a bank, and they have these normal cloud computers, and they tell me, all right, our standard cloud computer has 8 CPUs and 20 gigabyte memory. How many do you need? And in terms of machine learning, it's completely wrong to think about these computers, because what we know from the machine learning community is that the amount of data an algorithm sees has a lot of influence how good the algorithm is. So if you present the data at once, the outcome is much better if you present it in chunks on smaller computers. So we always want to have the biggest computers, and this is a big discussion then, of course, because they think the software might be bad, but that's not the case. It's the way machine learning approaches the subject that we need large computers.
Right. And is this where the cloud discussion comes back in? Because presumably they could migrate that to a test environment on a cloud, but are they concerned then about security and some of the other issues around that?
Yes, correct. Yeah. So when we go to the cloud, we also have our on-demand services in SmartStream. So we provide cloud environments, but then it's all about the ISO certificates and the SOC certificates and so on to provide that. And even on the cloud, such a computer running all the time is expensive. So you want to run it whenever you need it, right? Just 2 hours in the morning when we do our predictions for the business during the day, or again in the evening, an hour. So it needs a different way of thinking than the standard cloud environment. And when we have those discussions, I feel there is a gap, right, between the data science community and the cloud community at the moment. And that will advance, to answer your question. Yeah. We will see that in the next 2-3 years converging, and that will make a big difference for us.
So in other words, we're going to see banks will either upgrade their systems or they'll be using cloud more, and the way that their IT people work with you, they'll be speaking more around these issues around data science as you understand it, or as a fintech company would probably be native to it, as opposed to more traditional legacy IT kind of conversations.
Yes, correct. Yeah. So we will speak. They will more and more understand what the data science is, not only a software subject, but also a hardware topic. And that hardware topic has to be mastered. Yeah, right. That's correct.
Okay. Yeah. Very interesting. When we talk about explainability for a bank or an insurance company or an asset manager, what are the issues they have around explainability?
So let me give you an example, yeah, because it's much easier to explain by an example. We had some, when we started in the innovation lab with machine learning, and for example, we tried to predict data. Sometimes the machine was able to predict data, and we had no idea why it could predict that. So a data record came in, and our algorithm said, all right, that's from Bank of America. And we looked at the data, and there was nothing in there that is Bank of America. So we turned on explainability and starting looking at what were the reasons that it was classified as a record from Bank of America. And the algorithm actually used the blanks in that statement to identify that's Bank of America, because only Bank of America put blanks or spaces in the reference number at a certain position. I mean, it's nice to have that as a suggestion, but as a banker, if you look at that, it's useless, because you want to have a reference number, or you want to have BA somewhere in the reference number, and not having that classified based on something which is not data. It's just an indicator, right? And that is why it makes a huge difference for business users that we can mark why a machine learning algorithm has found something, because it means nothing to have 99% confidence in a prediction if it's based on non-data, right? Just metadata.
Right.
And that is why it's so important to give users insights that it was really a useful information the machine predicted on.
Okay, great. Well, let's talk about use cases a little bit. How do you see the way that financial institutions are using, the work that you do and AI in general? Do you see an evolution in terms of what they're able to do and what they're able to deploy?
Yeah, there's a lot happening at the moment. So I think the machine learning community has shown what we can do in financial services. There are a lot of fintechs, specifically actually in your market, in Hong Kong and Singapore. There are many good fintechs that work with financial services. And I think everybody has a good understanding now where the top use cases should be. On the other hand, it's more than just a data science use case. So if you look at the recent events that happened to a big bank in Europe or US, right, where they lost millions, and you look how what was the reason for that? It was really a bad user interface and a bad user experience that 3 people oversaw a mistake that was in a data record. So all the data we have, all the predictions we have also need better user interfaces, because we are generating with AI and machine learning even more data. And for a user, that's hardly digestible at the moment if you present him more data. So I think the evolution that is going to happen in the next 1 or 2 years is what we also do in SmartStream Air. We present the data context sensitive, so only what a user really wants to see needs to be shown. When an AI algorithm is clever, only give a user back the clever bit and not the whole data piece. We really have to make the applications more clever and present only to a user what a user needs to make the decisions on, base their decisions on, right? Not
Right.
all the data we have, that's useless.
Right. Okay. So there's an editing function that needs to be added to this, because there's so much data, and even though you're providing analyses, visualizations, I guess either a lot of the data is irrelevant, or it's just, people are just overwhelmed.
Yeah, it's both. It's the old user interfaces that are in banks are really 30 years old. They still use mainframes in many banks. And then we have those AI algorithms that, based on the data, produce even more data, and you cannot fit it on a text mask. So you need some clever pie charts, bar charts, and things that really are useful for a user. So I think in the next 2 or 3 years, we will see that the user interfaces will incorporate machine learning data more cleverly and will be much better for the user to use and to digest. It's not the case at the moment.
Right.
At the moment, it's more about having reports that are printed, and in the bank they then have this nice PDF that explains what's happening, but it's not interactive, mostly not. Right. And this is what needs to be done very soon.
Yeah. If I'm a COO or someone in charge, or a CTO at a big financial institution, what, listening to this, what am I thinking about what this is going to bring me, what I should expect from AI and services related to it today, and where can this take me? What can I go to my team and say, okay, guys, we've got this, this journey that we're on, and this is, these are some measurable benefits that we're going to be getting, and get excited about this stuff?
Yeah, so what we see at the moment is that the number of transactions worldwide are rising. So many departments have problems with their workload. So it's all about reducing manual touch points of users so that they do the standard things not manually anymore. And when you introduce machine learning, we have seen when we introduced Affinity, SmartStream Affinity, which is this observational learning algorithm, we can observe users, how they use their workflows. And after 3 or 4 days, we can already provide good suggestions. After another few days of observing, can really do their work. Basically, either really process things for them where the algorithm feels confident, or in the background as a quality insurance, where a user, when they click something and the algorithm does not, wouldn't do the same thing, there's a message popping up saying, do you really want to do it that way? The last days you have done it differently. So I think that the big arguments at the moment for machine learning really is that we can optimize the business. So we see 20% efficiency gain through Affinity, for example, in use cases. Then the work can be done earlier in the day, because if you automate it, it's done between 8 and 9. The hardware does that from 8 to 9, and not when you reach the SLAs at 2 o'clock, 3 o'clock. So you reduce the risk significantly by doing so. And you also increase the quality of the workflows, because they are done in the same way. It's not so human error prone, not so human dependent. It's like writing down a workflow. Machine learning also captures the workflow and standardizes it. So there are lots of benefits at the moment, and it's not very difficult to introduce machine learning into workflows. It's a thing that can be done easily these days.
Right. So the integration part is no longer such an issue.
No, specifically if there's standard software. So in SmartStream we have our reconciliation products, which are out there with many clients, and all it needs is an update to the next version. And then our machine learning components start computing and start increasing efficiency. We even implement it in a way that it has nearly no configuration that is required. So the clever bit is, if you have a software that already captured the workflows for many years, and then you upgrade it to a machine learning software, it can take all those data already and can have immediate benefits, right? This is the way as we see it. For us, it's the best way to introduce machine learning to a company. As I said before, it's like taking a standard product that you can trust, or making a project, a POC, where many POCs, when they are done, people leave, then the knowledge is lost. And as we know, software is getting old very quickly. So if it's not being maintained, in a few weeks, it will have the first problems, probably due to security topics, right? So software needs to be maintained, and therefore I see machine learning very much as a standard software. It needs standard products that are maintained by software providers.
Yeah. Okay. You've mentioned a few areas where your software is being used heavily. Reconciliations is one. I think we've also talked. I've talked with your colleagues also around corporate actions processing, processing payments. Where do you see right now, what's the most exciting area in terms of the work that you guys are doing? And maybe what do you think, will that remain the case for some time, or do you see your capabilities and what the AI and the software can do moving into other challenging areas for financial institutions?
Still the biggest topic for us is reconciliations. Reconciliations is not only a fintech problem, it's in every corporation. As soon as you reconcile, as soon as you have two data sets, you need to reconcile. And there are lots of regulations that require reconciliation. And only then you can work further and for example, send your data to regulators only when it's reconciled. Reconciliation is for us a big topic, and with SmartStream Air, we have a product which is very clever in many ways. It can onboard new data very quickly within seconds. It will provide reconciled data within a minute or so. So we have put all our intelligence and data science know-how into that product. And we see that we are at the moment approaching new domains where we have never been. So we have contacts to the mobile phone industry because they need to reconcile. We see that cryptocurrency providers need reconciliations. We have projects and customers in these areas. So our biggest focus in SmartStream, and it's a big area, yeah, is reconciliation, and also the whole workflow from the onboarding to the reconciliation itself, to the reporting, so providing management reports where disputes are, and then the whole exception management, which is also such an interesting area for machine learning, because then you have unstructured data, it's emails and phone calls and so on that need very different ways to approach it than structured data.
Yeah. Last question for you, Andreas. You're also at SmartStream, you're Chief Innovation Officer for blockchain as well as for AI. And you mentioned, we've been talking about reconciliation, which is predicated on traditional workflow processes. But if you're also doing this for some members of the crypto community, where does the work you're doing with AI and reconciliations meet that blockchain, or let's say, decentralized networks world?
Mm-hmm. So I think there's a misunderstanding that when you have blockchain, then every data is in sync, which is typically not the case. So what blockchain achieves is that where you are on the blockchain, the data is fully in sync, but there are always endpoints to that. When you have a cryptocurrency, you buy the cryptocurrency. So you have a payment process in there. When you're doing trade finance, for example, on a blockchain, then it's the process where you have to reconcile the documents against the blockchain, or where you have to reconcile again payments to the blockchain. So the endpoints always require reconciliation. So I think it's the perfect combination to have in a company to look at blockchain, which is for sure a future-proof concept. It's really great for so many domains, but also reconciliation, because it will still be needed very much when you have the endpoints of the blockchain. When you master the blockchain and the reconciliation, then you have the whole process that you can provide to clients.
Right. So it's the on-ramps and the off-ramps, the touch points to a blockchain network. That's what has to be reconciled within, I guess, on-chain processes. That's all flattened out, and it's just an immutable record that everybody's sharing. Yes, fascinating stuff. And so some of SmartStream's work, I guess, will be combining some of these different applications and next-gen technologies.
Yes, for sure. So in the innovation lab, we are always keen to look at all the innovations out there. We are looking at different blockchain technologies. We are using all the latest machine learning technologies. Many things are coming into SmartStream, are provided then with SmartStream products. But we look at much more than what you will see in the product. So it's and there's a lot coming up at the moment. Blockchain is, from where I see it, is still starting. It's still being, we still are trying to understand where it can be used. It's a very great technology.
Yeah, Great.
Mhm.
Well, then I look forward to having you back on the show sometime in the future when we've moved to the next level and we can talk about the next iteration. So it's been a pleasure speaking with you, Andreas. Thank you so much.